pleasure to make this presentation on the findings of task 5.1 of this DISCOVERER study, which is named EO Market Overview. I will make a general introduction in general aspects, then I will go a little bit further into the EO market. We will have a look into the EO data market, then the value-added services. We will have a look also into the market by verticals, and then I will show you 3 high-level profiles we have made or we have included in this task. This is not in scale, but just to have an idea on the differences between the different orbits that we can have, that satellites can use as of today. Within LEO, let's say we will have VLEO, which is downwards 400 kilometers. So we consider LEO from more or less 200 kilometers up to 2000, just to have an idea. But for us, VLEO is down 400 kilometers, since the major part of satellites as of today are upward 500, 600 kilometers. Then we have MEO, which is a middle orbit between LEO, which is the closest one to the Earth, and GEO, which is the one at 36,000 kilometers. And then we have the geostationary orbit, which is the most used in terms of, let's say, commercial companies, because of different features that we will discuss in just a few seconds. So once we have a view into these different orbits, this is just an overview on the number of satellites. So this, in MEO, for instance, we put 12 because we don't take into account the GNSS constellations. In these numbers of satellites, we don't consider satellites under 50 kilograms. We have around 150 satellites in LEO and more than 300 in GEO. As you might imagine, as you are closer to the Earth, the line of sight, the time that communications goes back and forward are lower, which is sometimes a merit and other times a demerit. So this also has another constraints, as the time you can have a tracking of the satellite, the time of line of sight of the satellite, how much is the time you can have visibility and you can have communication with the satellite, which is the best in GEO, because it's always there. You don't need to move the antenna. It's always pointing the same point. Everything perfect. Everything works fine. In MEO, this changes, so you can have visibility of 24 hours in GEO. In MEO, this changes, and this visibility time is reduced to 2 to 4 hours. And in LEO, and when I say LEO, I'm talking about 600 kilometers to 1,000 kilometers. We can have a visibility time of around 15 minutes. In terms of merits by orbit, obviously we have lower launch costs, we have lower path loads in terms of communications, we can have higher resolution, which is one of the major merits that we are looking for in DISCOVERER. So these are pros of LEO. Cons, there are some as well. We can have shorter lifetime of satellites because of different reasons, but most important is re-entry in the atmosphere and perturbations that are different compared to other orbits. We have a smaller swath, which means the big picture we see if we have a look into the Earth from the satellite. So the picture we see is smaller if we compare to other orbits. So the closer we are, the less we see in terms of total picture. As I said, we need to make a trade-off between different features, between different parameters. So we have geographic coverage, response time, revisit time, on-ground resolution, and swath. We need to take into account that if we touch some of the parameters to improve geographic coverage, for instance, immediately this has an impact on the other features. So at the end of the day, we need to make a trade-off between all these parameters and much more in order to match best we can to solve and to give an answer to the demand of the market. So once we have seen the different trade-offs that we need to consider for the design of the constellation, then we need to match these design or engineering aspects with the market and what the market needs. So if we take into account what is needed or demanded by applications as agriculture, forestry, geology, etc. Most of these users will need images around 5 to 15 meters of ground resolution with not a high revisit time required. Basically, in average, they will not need a high revisit time, neither high resolution. This changes if we go into another market. For maritime, this changes. For cadastral, it changes. Risk management or difference, it changes. We usually need more resolution with a lower revisit time. So again, we need to match both market and technical aspects to give the best answer we can. So if we want to provide a good system, we will need to consider different things. Resolution matters, but it's not the only thing that matters. So it's very good to have high resolution, but at what price? Revisit. So if we want to have satellites in very low Earth orbit, means that if we want to have a high revisit, we will need to have a constellation with lots and lots of satellites. The accuracy of the images we take. The accuracy is also very important for some markets, as for defense. So it's not only resolution, but also the accuracy on the image that satellites are taking. Spectral bands. So we have different spectral bands. It's not only visible, but we need as well some other wavelengths if we want to deliver what is needed by other end users, by other markets. So this is in terms of, let's say, data market, which is only the way can we process the data from the satellite to the end user in a first stage. And then the second step on the value chain is what we do with this data. And that's the key. It's going to be applied to some application. It's going to be used by Google to make the Google Earth. So these are value-added services. And this is what we need to think about to give a boost to potential applications that can derive from Discoverer. So in terms of data market, so the first step of the value chain, we have different definitions. This is one definition from NASA, but you can find other definitions from other parties. More or less similar, but the description and the definition of each of these level of treatment of image can be different from one source, from one institution to another one. So once we are taking a picture from the satellite, this picture is sent to a ground station. This ground station needs to first make the first separation, and then you need to process the image. You need to take into account the configuration that the payload has at that moment, the inclination, etc. There are different aspects that need to be taken into account in these first levels of data product. So once you make this, then you need to georeferentiate the image. You have to take into account different reference points to compensate potential errors that the image can have because of the tilt of the satellite and other aspects. And then we go into something more complicated or more applied to specific demands, which are value-added services. So in this case, here in the left side of the slide, you can see different types of processing steps on one image. So this will be one image, not compensated with inclinations, etc. And this is the process up to something more elaborated, which we can see heights, etc. So from here, we can make a differentiation in one picture on which parts of the image are forest, which part are buildings, which ones are roads. So we can make this type of value-added services to target and to give an answer to different end users as infrastructure ministries or infrastructure companies, etc. Other things that we can do is in disaster management. Here we have an example of a landslide which happens in a forest. So here we can have an idea on which parts of the road are affected at a given time. So the idea of this task 5.1 was to fix the perimeter and to give some inputs to other tasks and to give overview on what's the business now and what are the expectations of the business in the coming years. So we make a general introduction to the EO market. As I said before, we can differentiate the market into two different parts. So the first part is from the moment we take the picture to the moment we make the first process of the picture, which will be included in this first commercial EO data market. And then we have the value-added services. And I will read this because I think it's very important to make this difference. So this is based on the raw data or low-level rectified imagery. So I think it's clear. And then value-added services. So we consider the value brought by taking data, and it can be commercial, free, or scientific, and developing a product. A product can be Google Earth, but also other things. So imagine you can take, and is the case, you can take for free data from Copernicus, from the European Commission. You take this data, and then you make your applications. So this is value-added services. You are taking something and you are creating anything, something new. So you develop a product, service, or research through analysis and image processing. The point of what is considered value-adding can vary by companies, can vary from one stakeholder to another one. So moving data from raw imagery to a geo-rectified product is another value. However, for the purpose of this study, we have considered as value-added the point that imagery moves to something, an application on a vertical market in specific. So something more applied that level 1, 2, 3 image. Here we have a view on the value chain and figures on the value chain for 2016. Here we have the upstream and here the downstream. So to start with the upstream, basically so far the major funders of Earth observation programs were governments. Governments and institutions or multinational institutions as ESA. For EO, but also for scientific research. More and more we are seeing that there's more interest for private investment for different several reasons, but basically coming from the US. And this is obviously having an impact in the whole value chain. So basically, this is an average. We have taken an average of the last 10 years to derive these figures. Why? Because as you know, one satellite is not paid at one time. And one satellite can vary from some tens or hundreds of thousand euros up to some hundreds of million euros. So it's a wide range. So this is first thing. Second thing is related to the process of payment. So from once this program is started, or let's say is accepted, till the satellite is ordered and then paid, it takes time. So it's a process that takes several years. So when we heard that a program cost, 500 million, it's not paid in 1 year, it's paid in different years. So in order to make an average and to have a more accurate idea on each year by year figures in terms of the upstream of the value chain, what we make is an average on the last 10 years. So in this situation, we had these results. So manufacturing 1.7 billion, 2006 in average, but let's assume for 2016, 630 million for the launch, which if we compare to the launch for commercial satellites in GEO is much smaller. But we see that more and more we have newcomers into the launch arena. So this is a potential market of growth, so important to bear in mind. Ground operation and ground segment and operations will make more or less an estimate of 10% of the total of the upstream, more or less. And then we have the downstream. In the downstream, we have, as I said before, two parts. The one referred to the data market and the one referred to the value-added services. We can have commercial operators, government operators, data distributors, which are in the middle of everybody. And then we can have companies that are just making value-added services. Some of these companies of commercial operators are also distributors and make also VAS. And then obviously it comes to the end users that can be from governments to farmers. So as of today, mostly were governments investing in the sector. Now this is changing. So we will see that from governments it will go to commercial operators in terms of prominent operators in the next years. We go from 35 countries with EO satellites up to 48. In terms of satellites, EO satellites of more than 50 kilos, from 190 multiplied by 4. In terms of manufacturing revenues, it's not multiplied by 4, but it is because the complexity of the satellites, and it is because it's related to the size and the cost of satellite, which is lower if we compare single dedicated satellite for specific missions compared to satellites which are manufactured for a constellation. In terms of revenues, in the data commercial world, it's a factor 2. It's also a factor 2, but in terms of final figures, is almost the double for value-added services compared to data market. So when we are considering 180 satellites in the last decade and 600 satellites in the next decade, we are considering this change of paradigm in terms of constellation. So we assume that most of the satellites we will be launched in the next 10 coming years will be part of commercial constellations. So regarding the EO data market, here we go into more details on revenues, year by year, by type of customer. This is data sales by data type. So as you can see here, these gray bars are referred to the US defense. So it's basically the data which is consumed and paid by the US DoD. In blue, we have the other governments, the other ministries of defense of the rest of the countries, which is basically the 70% or the 65% of the total each year. So it's important to have this in mind. And then in red, we have the non-defense markets. In terms of data type, just to give you an idea, very high resolution, so less than 1 meter, which is what we are looking for with DISCOVERER, is the most important data type from 2007 to 2016. So there's a market, there's a need of very high resolution data. This is data, this is not added value services, but data. So at least in data, there's a market. There was a market in the past and there's a market in the future. High medium resolution, so from 1 to 10 meters. This size, which is more or less at 10%, and the other 10% is synthetic aperture radar, so radar imagery, which is not a telescope or a photographic camera, let's say, but an antenna that collects information in radio frequency. Who will use what in the future? This is what we expect the market will go in the next decade. So as you can see here, in terms of data market demand, as only data, not value-added services, will remain more or less stable for the US defense, for the US DoD. It will increase for other ministries of defense because of newcomers in terms of use of this data. So new countries as Morocco launching EO satellites for defense, or other countries, but also current countries as European countries having more capabilities. And then we see here that we go from more or less 20-25% on non-defense market, commercial market, to something more like 35%. If we have a look in the type of data, again, very high resolution, we'll have mostly the demand in the future. So more or less in the same range as of today. Broken down by vertical market. In 2016, the defense made 60% of the demand, and then we had infrastructure, natural resources, energy, location-based services, maritime, disaster management, environment. What do we see in the future? In the future, up to 2026, we see that vertical markets as infrastructure and location-based services will grow in data in the data market in the future. This will change for value-added services, but in the data market, we see that the major growth, the major potential of growth will come from location-based services and others as infrastructure. If we have a look in terms of region, obviously North America and the US DoD, major user of EO data in the future. Latin America and Asia will increase the use of Earth observation imagery for different reasons, but very important to understand that some of the countries of Latin America, some of the countries of Asia are already launching or preparing their own national programs. So the summary of main findings on this data market: we have in the last 10 years accumulated commercial data revenues of 30.5 billion. In the next decade, we expect that this will almost double up to 25 billion. Main vertical market will keep being defense with very high resolution data. The US DoD will be the most demanding user, but the share and the proportion will change. So this is important to keep in mind. So now in the value-added services, this changes a little bit. If we have a look in the picture as of today, we see that for value-added services, on the opposite of the data market, where we saw that defense represented the 60% of the total in terms of revenues, here it represents the 15% of the revenues. Why? Because first, most of the applications that defense needs don't need value-added services, and if they need value-added services, they cook it themselves. So it's made by themselves, it's made by their own, and they don't depend, usually, sometimes yes, but they don't usually depend on third parties. However, other vertical markets as infrastructure, environment, natural resources, here, as of today, they have a major demand in terms of this type of data. At the moment, location-based services, this represents a very small portion in terms of revenues on value-added services. But in terms of growth, so this is the conservative scenario. This type of services in particular, we have a higher growth in the future. So here we are talking about a market in 2016 of more than 3.5 billion. So a big market where infrastructure and environment are the biggest vertical markets. In the future, this will change a little bit, basically with location-based services, but the share will be more or less similar. Now, if we have a look into these different verticals that I just showed you in terms of situation in the past and projections we make for the future, my idea on these next slides had two different objectives. The first one was to show you and to make you understand that different sources, very high resolution, medium resolution, SAR data, infrared data, they have different applications. So this is one thing. And the other thing is the application on the key markets. And this is it from my side.